All right, let's go for it. So 7.4, the word problem section, the applications. One of each type, and there's the number problem, then there's the interest problem, it's the coin problem, and the mixture problem. You'll see that these have repeated themselves, and so because now we have an x and a y variable, these problems actually have become a little bit easier than the ones we've done before, because now we can work with two different variables at the same time. Second thing is the process. If you sort of start looking at the process, this process is very similar for each of these four different problems. You'll sort of see like, oh, got it, you do this, then you set up the equations, and then from there you solve. Okay, so we have some choices as well. You can solve it by graphing. Probably not a good choice. So I'll give you a choice of solving it by substitution method or solving it by the elimination method. That's kind of going to be your choice, which one you really want to solve, which way. Probably going to use elimination most of the time. If you see a variable that's already been solved for, probably substitution. That's kind of the way we're going to work it here. So let's go for it. First one is the number problem. So in this case, since we have two different variables, what we're going to do is we're going to define each of those variables. We're going to say x is this, y is that. So one number is 4 more than 1/2 another number. Got two numbers on my hands, so here it is. How about x is going to be one of the two numbers, if you like, the first number, whatever you like. You just sort of label one of the variables. You can write the first number if you like. Then y would be the second number. If x is one of the numbers, then y would have to be the other number. That's all. But you're just sort of giving that a label. Again, on the number problems, there is not going to be that as important as it will be later on as we define certain things. Okay, but now the question is, can I get two equations that symbolize what it says? So one number is 4 more than 1/2 another number. Okay, on these ones, it doesn't matter which one it is. You could put x is equal to that, or you can say y is equal to that, because they're both going to be the same. They're just getting a relationship between the two numbers. So in this case, since y is the one that we always normally equal everything to, let's put y equals. So the one number is going to be the y for us, okay? So again, doesn't matter if you just switch them either. So one number, that we're going to call it the y. Let's see, is equal sign 4 more than. Remember, more than works backwards. The 4 is going to be all the way at the end. And then 1/2 another number. Everybody good there? So one number, which is this guy, is 4 more than 1/2 another number. And at this point, it wouldn't matter if you switch the x's and the y's, because you're getting a relationship between the two numbers. Find the two numbers if their difference is 2. Okay, so let's go for it here. Find the two numbers. So I got to get a difference between these two numbers. So minus sign. All right, I got my two equations almost set. Substitution or elimination? Substitution this time, yep. The y is going to plug in as 1/2 x plus 4. So let me rewrite it over here. Da-da-da-da-da, and da-da-da. And all yours to solve. Give you a minute, try it yourself. Again, this would be a good practice just to do the elimination and the substitution method. Alright, I'm going to start it as well here. So the bottom equation is x minus, and then parentheses 1/2 x plus 4 equal to 2. That negative has to be distributed inside here. So how about a negative 1/2 x? How about a minus 4? Hopefully we got that this time. And at this point, again, you could try to put things together. I probably wouldn't. I'll probably just multiply by 2. Let's get rid of our fraction, and then we can work with the rest of it. So multiply both sides by 2. So 2 times x, 2x. 2 times a negative 1/2, which makes negative x. 2 times negative 4 is negative 8, and a 4 on the other side. gathering the x's together on the left-hand side. 2 minus 1 is a 1, so you get x minus 8 is equal to 4. And how about let's add 8 to both sides. It gives us x equals 12 is good. At that point, again, it doesn't matter which equation you want to use, but still the easiest one is the one that's already been solved for the other variable. So how about y is equal to now 1/2 of 12 plus 4. Alright, at that point, let's see, that's going to be 6, and 6 plus 4 make 10, and we get ourselves the y value. Okay, so it is, you can't just say 12 comma 10, because there's no x's and y's in our original problem. So it has to be an English sentence somewhat. And so in this case, we could say the numbers are 12 and 10. All right, good there. Okay. Next one. So that was the number problem. Number problem. Finishing it off. Doesn't really matter what the x and y is. You just sort of label either or. You'll wind up with, as long as you're using your own equations, you'll wind up with the correct answers here. So let's go on to the interest problem then. Again, I think we've seen this before. Okay, we'll see that since we have two variables now, this one becomes a little bit easier of a problem to handle. But this time the x and the y, we do have to label them, and we have to keep those labels correct. So first things first. Let's see, Mr. Richard had $10,000 to invest. He invested part of it at 5%, the rest at 9%. If he earns $825 in interest, how much did he invest in each account? The little each account sort of tells me. X would then have to be equal, maybe like amount invested at 5%, maybe something like that. Because those are the two accounts. The rest was invested at 9%, so how about y would be the amount invested at the 9%. Okay, and once we have that, I think we actually have even enough information to set up our two equations right away. So the first equation usually is typically just the amount only. How much was invested altogether? It was 10 grand, is that right? So how about this, see if this makes sense. The x plus the y would give us $10,000. It is just the total amount invested. It's that first sentence there. And again, we'll see number 3 is going to work very similar to this one. So once you get number 2, number 3 should be a little easier as well. So it's just flat out just the number invested. What's the number of items here? Sometimes we call it a quantity relationship. Just that without the percentages. Okay, the next one is going to include the percentages. Now we're talking about interest. So see if this makes sense. Since the x is the amount at 5%, the interest at 5% is really 0.05x. Good there? There's your 5% of x plus 9% of the y, because that's what it is at 9%, So now that's the 5% and the 9%, and the grand total is how much interest earned as far as percentage goes. 825. Cool. There's my two equations. And again, we'll try it again with number 3. I think once we see number 3 is a bit easier as well. Okay, if that is the case, now we think about substitution or elimination. I think I want to do elimination as well. I'll do substitution in the next one here. But first of all, I don't like these decimals here. So is there a way to get rid of these decimals? Yeah, just like fractions, right? Remember we don't like fractions in here? We're going to work a little bit on this bottom equation just to get rid of the decimals. And we have to multiply. Let me actually rewrite this since I'm going to run out of room here. So there's my first equation, second equation. I'm going to multiply this bottom by 100. You got it. Moving the decimal twice. So just like we tried to get rid of fractions. The top, no change. So x plus y equals 10,000 on top. That's cool enough. On the bottom, now I got myself a 5x. 9y, is that right? And I got an 825 with 2 extra zeros now added to it. Okay, got rid of my decimals, or technically got rid of fractions, because decimals and fractions are sort of the same. Okay, now the question is, what should I do to make opposites? My thoughts exactly. Let's multiply the top by a -5. You could do it with a -9, but why choose bigger numbers when you don't have to? Okay, on the bottom, no change. So NC for the bottom. Alright, hopefully I'll let you guys out a little bit here. Let me try it as well here. So I got a -5x, -5y is equal to -50,000. On the bottom, everything else stays the same. When I add them up, the x's are gone as planned. How about a 4y is equal to, and anybody with this one? 32500, that's what I got. Everybody good there with that one? Cool. If that's the case, divide by 4, and I get y is equal to 8,125. Okay, that's the y value. Anybody check here? Does it need another 0? No.
Yeah.
32,000. It is 32,500.
Right there. It's 32,500 divided by 4.
Okay. Check it here. Everybody else agreed with what I have on the screen?
Yeah, it's right here.
Okay. Alright, so real quick here, I got the y, I need the x, but I know the relationship, x plus y equals 10,000. So then let's see, if the grand total invested was 10,000 and I invested 8,125 for the y, what was invested as x? $1,875. That's what I got as well. Okay. Now we got ourselves a little problem here. So I need an English sentence, and I need to know which one's which. So the 8125 belongs where, or to which account, and the 1875 belongs to which account. So you have to delineate which one's which.
So 1,875 was invested at the 5%,
Mm-hmm.
and 8,125 at the 9%.
Perfect. Okay, cool. And then you got the units. What's the units on these numbers? Dollar signs. Perfect. So I got $875 was invested at 5%, and $8,125 was invested at 9%. All right, a little bit of a tough one. Got some big numbers here I had to deal with. Next problem, number 3. Let's see if we can sort of put this together. Again, smaller numbers, it works the exact same way, but I think you guys can probably set up the two equations sort of easily here as well. So let's go for it here. Number 3. So John has $2.30 all in dimes and nickels. He has a total of 28 coins. So how many of each kind does he have? There it is. So the two things we don't know. Let's put it together here. So what is x? What is x would be?
X would be that X, Y would be that X.
Perfect, yeah. And then again, you got to sort of think of which one's which. I sort of did it backwards here. I don't know why when I did this here. I put x as the number of nickels. Doesn't matter. And y would be the number of dimes. Now when you label them like this, then when you do the problem itself, then you got to think about how you're going to put them in. Okay, so first equation, the easy equation, is the quantity equation. Just how many stuff do you have? What would that look like?
X plus Y equals 230. X plus Y equals 28.
Yeah, x plus y, just the stuff themselves without any values to them. It's kind of like the $10,000, right? It's just the grand total. So in terms of just coins only, x plus y equals 28. Okay, now let's put in the values now. So a nickel is worth 5 cents, a dime is worth 10 cents, and then the total worth. So can you write that equation? Just so we don't get too far ahead of ourselves here. How about 0.05x plus 0.10y is equal to 2.30. Are we good there? All right, and then again, I got these decimals to deal with. What should I do?
5 plus 10 plus 230.
Perfect, yeah, multiply the bottom by 100. The top, no change, so x plus y equals 28 still. And the bottom now becomes 5x plus 10y equals 230. All right, I'll let you guys finish it off. Let's see, I think most of you guys will choose to multiply by a -5 on top. If you want to do the exact same steps that I did, what I did is I multiplied by -10. How come I would multiply by -10?
Up to what?
It's just easier to multiply by 10 as opposed to 5. That's all.
Get a 0.
Yeah, just stick a 0. So, but anyways, any which way you choose. Multiply by -5 or multiply by -10. If you want to do the same thing I did, multiply through by -10. Still should come up with the same answer. So give you guys a minute, try it yourself. Alright, I multiplied through by -10 because it's in my mind it's a lot easier to multiply through by -10 because you're just adding an extra 0 onto things. So -10x minus 10y is equal to a -280. On the bottom, no change. Because of that, the y's are going to disappear. So I got a -5x is equal to a -50. And voila, hopefully you got something called x is equal to 10. Is that right?
Mm-hmm.
All right, this number here, and it should be a whole number. Is that right? Or else something went wrong, right? Can't have 10.5 on this one. All right, if that is correct, and you got 10, what is this, 10 nickels, that means the number of dimes would have to be 18. Cool. English sentence, here it is. So I got 10 nickels and 18 dimes. All right, and the next one. This one gets just a little bit complicated. Again, same exact process works. Since I can define two variables, I can define. I'm going to do this also in terms of a grid, just so you guys can see it. You can actually do a grid with these as well, just so you see it. Okay, so how much? 30% alcohol solution and 100% alcohol solution must be mixed to get 10 gallons of a 72 alcohol solution. Now we're not mixing vodka here. We're probably too much for alcohol here. All right, let's go for it here. So let's define x is equal to, let's see, number of, mixing gallons here, right? So gallons, so there's number of gallons of, and I guess the two mixtures are a 30% solution. Then y would be number of gallons of 100%. So now this little 100% is going to be a little bit weird for us, but I'm glad it's on the practice problem here. Okay, out of curiosity here, just out of curiosity, can you go and make your two equations? Just kind of think about what would be the first. Don't write it down, but let's think of the first equation. First equation would be what? X plus y equals 10. Perfect. Done. Second equation.
0.30 x plus. Would it be 0.30 or just?
0.30 or 0.30. Because of the percentage. Now, right now we're including percentages, right? So the only little issue here is, and you know what? No, let's make. I won't do the grid line here. Actually, I'll do it with you guys, because this should be. So first equation is just the quantity equation only. X plus y equals 10. That's my quantity equation. We good? No percentages, just the number, or just the number of types. Okay, the second equation. Now we put in the percentages. So everybody okay with the 0.30x? Okay, now here's a little problem. The 100%. How'd you do 100% of y? Won't be 100y though. Because remember, 30% came in as 0.3. Cool. It's going to be 1.00, right? Because that'll be 100%. But when you bring it in, you can actually just bring it in as just a y. Good there, because that's 100% right there. Okay, this is the trouble. The students come in right here. We need to get 10 gallons of a 72% solution. 72. Okay, here's our little trouble. Remember with the interest problem, the interest was already 825, right? This one, here's a little problem here because we have. Let's look at it this way here. Notice this is the percentage. The 0.30 is the percentage, right? And x is how much, right? Over here is 100. That's the percentage. And y is how much. We good? So over here we need the percentage. And then how much? You need that little extra 10 in there. We good? Which we don't get from the interest problems. So that's really the difference between a mixture problem and an interest problem. Because the interest is already given. We could have also said you had 8.25% of $10,000. And then that we should have found that out to be 825. Okay, so good there. With mixture problems, this little last piece right here, you got to put in percentage and the quantity. Okay, so simplifying this out a little bit here, so no change at all here. I'm just going to simplify the little bottom right here. So 0.30x plus y is equal to 7.2. Is that okay with everybody? It's 0.72 times 10. Okay, so as usual here, what should we do to get rid of decimals, because we don't like decimals? So this one, notice if you put this decimal, if you move it over once, you'd actually get a 3x already, right? We don't need to move it over twice to get 30x, because we only need to move it once over here as well. So I'm only going to multiply by 10. So x plus y equals 10 for the top equation, because there's no change. On the bottom, it's just going to be a 3x plus 10y is equal to 72. All right, all yours to finish off. But out of curiosity here, what did we multiply by to get opposites?
-3.
Awesome. Okay, cool. We learned it. We learned it. So the top equation we're going to multiply by -3. The bottom is going to be a no change as we get our x's to be the opposites. So writing it out over here on the left-hand side of the screen, -3x minus 3y gives you -30. 3x plus 10y gets you 72. Alright, let me finish off the problem here as you guys are doing as well here. So the x's are gone, the y becomes a 7y is equal to a 42, is that right?
Yeah.
Divide by 7. 6 is perfect. Now in this case, we could actually get decimals, right? Because you can have 6.5 gallons, right? 6 3/4 of a gallon. Yeah, those necessarily have to be a whole number. Okay, and this one's easy. If y is equal to 6, you know the grand total is 10. What does x have to be?
4.
Yeah, without even doing any work whatsoever, you know x has to be the 4. Okay, if you wanted to, just to verify, it has to work out algebraically, of course, because the y turns into a 6. Subtract 6 from 10, and we get that 4 that we needed. And alright, the English sentence, all yours for the English sentence.
4 gallons of the 30% and 6 gallons of the 20%.
Perfect. Yep, 4 gallons of, and then we got to know which one it is, of the 30% solution, and 6 gallons of the 100% solution. All right, and that concludes Chapter 7 as we finish off 7.4.